Hello everyone, I'm Professor Diwa, and welcome to another math video. In this video, I'll be going over multiplication and division of rational expressions. Our objectives are to find the domain of a rational function, simplify rational expressions, multiply and divide rational expressions, use rational functions in real-world applications. Alright, so let's get started. Rational expressions and functions. It states here that a rational expression is an expression that consists of a polynomial divided by a non-zero polynomial. Below we have some examples. We have 8x cubed plus 7x squared plus 20, all divided by 2. We also have 5x squared minus 3, all divided by x minus 1. And finally, we have 7x minus 2, all divided by x squared minus 2x minus 15. Next, we're going to go over rational functions. Let p of x and q of x be polynomials, then a rational function is given by f of x equals p of x divided by q of x. Now, a rational function is essentially just a fraction with a polynomial on the top and the bottom. Now, just like any fraction, we cannot divide by 0. So the domain of the function f includes all x values such that the polynomial in the denominator q of x is not equal to 0. For example number 1, find the domain. For part A, we have f of x equals 8x cubed plus 7x plus 20, all divided by 2. To find the domain of any rational function, we just see what x values results in 0 for the polynomial in the denominator. You could see here that we have a constant value of 2 in the denominator, which means that we could use any x value for this function, and the denominator will never be 0. So our domain, written in set notation, would be curly brackets x such that x is a real number, or in interval notation, we have parenthesis, negative infinity, comma infinity, close parenthesis. Moving on to part B, we have the function f of x equals 5x squared minus 3 divided by x minus 1. To find the domain of this function, we just look at the polynomial in the denominator. We have x minus 1 in the denominator. We want to figure out what x values would make the denominator 0. So we take x minus 1 and set it equal to 0. When we solve for x, we just add 1 to both sides of the equation. We get x is equal to 1. This means that we cannot use the value of 1 because it results in 0 in the denominator. So we write our answer for the domain in set notation as curly bracket x, a vertical line, x not equal to 1, close curly bracket. Or we could write our answer in interval notation, which is parenthesis, negative infinity, comma 1, close parenthesis, union, parenthesis, 1 comma infinity, close parenthesis. Moving on to part C, we have the function g of x equals 2x divided by x squared minus 3x plus 2. To find the domain, we just take the polynomial in the denominator and set it equal to 0. We go ahead and solve for x by factoring the trinomial. We can use the x method to factor this. The product on the top of the x would be 2, and the sum on the bottom would be negative 3. The two numbers that multiply to give us our product and add to give us our sum is negative 1 and negative 2. So we go ahead and rewrite the trinomial as parentheses x minus 1 times the parentheses x minus 2 equals 0. Next, we apply the zero factor property. We take each factor and set it equal to 0. We get x minus 1 equals 0 and x minus 2 equals 0. From here, we solve the first equation for x. We just add 1 to both sides of the equation. We get x is equal to 1. Next, we solve the second equation for x. We just add 2 to both sides of the equation. We get x is equal to 2. Since we got the value of x equaling 1 and x equaling 2, this means we cannot use those two values because it results in 0 in the denominator. Writing the domain in set notation, we write curly bracket x, a vertical line, x not equal to 1 comma 2, close curly bracket, or in interval notation, we write parenthesis, negative infinity comma 1, close parenthesis, union, parenthesis 1 comma 2, close parenthesis, union, parenthesis 2 comma infinity, close parenthesis. Next, we have a practice problem. Find the domain. For part A, we have h of x equals 2 divided by x minus 3. For part B, we have f of t equals t divided by t squared minus t minus 2. For part C, we have g of x equals x cubed minus 9x, all divided by 5. Alright, so go ahead and pause the video, find the domain for each problem, and then check back with the video to see the solutions. Alright, so let's go ahead and find the domain for part A. We start by taking the polynomial in the denominator, x minus 3, and set it equal to 0. So we get x minus 3 equals 0. Next, we solve for x by adding 3 to both sides. We get the result is x equals 3. From here, we could write our domain in set notation, which is a set of curly brackets, x such that x is not equal to 3, or we could write our domain using interval notation. I have parenthesis, negative infinity, comma 3, close parenthesis, union, parenthesis 3 comma infinity, close parenthesis. Moving on to part B, we take the polynomial in the denominator, t squared minus t minus 2, and set it equal to 0. To solve for t, we need to factor the trinomial by using the x method. The product is negative 2, and the sum needs to be negative 1. The two numbers that give us our product and our sum is negative 2 and positive 1. So we write parentheses t minus 2 times parentheses t plus 1 equals 0. Next, we apply the zero factor property. We get t minus 2 equals 0 and t plus 1 equals 0. Solving the first equation for t, we just add 2 to both sides. The result is t equals 2. Solving the second equation for t, we just subtract 1 from both sides. The result is t equals negative 1. Our domain written in set notation is a set of curly brackets, t such that t is not equal to negative 1, comma 2. Or we could write our domain in interval notation, which would be parenthesis, negative infinity, comma negative 1, close parenthesis, union, parenthesis, negative 1, comma 2, close parenthesis, union, parenthesis, 2, comma infinity, close parenthesis. Moving on to part C, we need to find the domain of g of x. You can see in the denominator, we have a constant value of 5. In that case, we can use any x value for this function. So our domain written in set notation would be a set of curly brackets, x such that x is a real number, or in interval notation, we write parenthesis, negative infinity, comma infinity, close parenthesis. Next, we have the fundamental principle of rational expressions. It states here for any rational expression p divided by q and any polynomial r, where r is not equal to 0, we have pr divided by qr is equal to p divided by q times r divided by r. This is equal to p divided by q times 1, which is equal to p divided by q. What this principle is telling us is that we could cancel out any common factors on the numerator or denominator of any rational expression as long as the operation between the terms is multiplication. For example number 2, simplify each expression. For part A, we have 2x squared divided by 10x cubed minus 2x squared. To simplify this expression, we can factor out a common factor of 2x squared on the denominator. We get 2x squared divided by 2x squared times the parentheses 5x minus 1. From here, we could cancel out the common factor of 2x squared on the numerator and the denominator. The result is 1 divided by 5x minus 1. Now this expression is fully simplified. Moving on to part B, we have 2z squared minus 3z minus 9 divided by z squared plus 2z minus 15. In order to simplify this expression, we need to factor the numerator and the denominator. Factoring the numerator and the denominator, we get parentheses 2z plus 3 times parentheses z minus 3 divided by parentheses z plus 5 times parentheses z minus 3. Next, we could cancel out the common factor of z minus 3. The result is 2z plus 3 divided by z plus 5. This expression can't be simplified any further, so this is our final answer. Next, we have a practice problem. Simplify each expression. For part A, we have 3y cubed divided by 6y to the 4th power minus 3y cubed. For part B, we have z squared plus 2z minus 8 divided by 3z squared minus 7z plus 2. Alright, so go ahead and pause the video, simplify each expression, and then check back with the video to see the solutions. Alright, so let's go ahead and go over part A. On the denominator, we could factor out a 3y cubed. The result is 3y cubed divided by 3y cubed times parentheses 2y minus 1. Next, we cancel out the common factor of a 3y cubed on the numerator and denominator. The final result is 1 divided by 2y minus 1. Moving on to part B, we need to factor the numerator and the denominator. The result is parentheses z minus 2 times parentheses z plus 4 divided by parentheses 3z minus 1 times parentheses z minus 2. From here, we could cancel out the common factor of z minus 2 on the numerator and the denominator. The result is z plus 4 divided by 3z minus 1, which is our final answer. Next, we have example number 3. Simplify each expression. For part A, we have x cubed plus 8 divided by x plus 2. To simplify this expression, we need to factor the numerator, which is the sum of cubes. So we need to use the sum of cubes formula, which is a cubed plus b cubed equals parentheses a plus b times parentheses a squared minus ab plus b squared. Next, we need to figure out what our values for a and b are. The value for a will be the cube root of x cubed, which is x. The value for b is the cube root of 8, which is 2. Next, we substitute our values for a and b into the formula. We get parentheses x plus 2 times parentheses x squared minus 2x plus 4 divided by x plus 2. Next, we could cancel out the common factor of x plus 2 on the numerator and denominator. The final result is x squared plus 2x plus 4. Moving on to part B, we have 2y squared plus 2 divided by y cubed minus 5y squared plus y minus 5. We start by factoring out a common factor of 2 on the numerator and then factor by grouping on the denominator. The result is 2 times the parentheses y squared plus 1 divided by parentheses y cubed minus 5y squared plus parentheses y minus 5. Next, we could factor out a common factor of y squared from the first grouping in the denominator. We get y squared times the parentheses y minus 5 plus parentheses y minus 5. And then on the numerator, we still have 2 times the parentheses y squared plus 1. Next, we could factor out a common factor of y minus 5 from the two terms in the denominator. We get parentheses y minus 5 times parentheses y squared plus 1, and on the numerator, we still have 2 parentheses y squared plus 1. Next, we could cancel out a common factor of y squared plus 1 on the numerator and denominator. The final result is 2 divided by y minus 5. For example number 4, simplify each expression. For part A, we have 2 plus x divided by x plus 2. What we could do is just rearrange the terms on the numerator. This will give us x plus 2 divided by x plus 2. Now we could see that we could just cancel out the x plus 2 on the numerator and the denominator, which will give us 1. For part B, we have 3 minus x divided by x minus 3. The first thing I'm going to do is rearrange the terms on the numerator. We get negative x plus 3 divided by x minus 3. From here, we're going to factor out a negative from the negative x plus 3 on the numerator. We get negative parentheses x minus 3 divided by x minus 3. Next, we cancel out the common factor of x minus 3 on the numerator and denominator. The final result is negative 1. Moving on to part C, we have negative y minus 2 divided by 4y plus 8. Starting off on the numerator, we could factor out a negative from both terms, and on the denominator, we could factor out a common factor of 4. The result is negative parentheses y plus 2 divided by 4 times parentheses y plus 2. Next, we could cancel out the common factor of y plus 2 on the numerator and denominator. The final result is negative 1 divided by 4. Next, we're going to talk about multiplying rational expressions. The rule for multiplying rational expressions is p divided by q times r divided by s is equal to pr divided by qs, as long as q is not equal to 0 and s is not equal to 0. Now, the reason why they stated that q and s cannot be equal to 0 is because we're working with fractions. And remember, we cannot divide by 0 whenever we're working with fractions. So what this rule is telling us is when we're multiplying two or more rational expressions together, we could combine them together all under one fraction using multiplication. Next, we have example number 5, multiply. For part A, we have 3n plus 1 divided by 2n times 2n minus 4 divided by 3n squared minus 2n minus 1. So the first thing I'm going to do here is factor out a common factor of a 2 from the 2n minus 4, and then also factor the trinomial 3n squared minus 2n minus 1. The result is 3n plus 1 divided by 2n times 2 times the parentheses n minus 2 divided by parentheses 3n plus 1 times parentheses n minus 1. From here, we could cancel out the common factors of the 3n plus 1 as well as the 2 on the top and bottom of our rational expression. The result is n minus 2 divided by n times parentheses n minus 1. Moving on to part B, we have x cubed minus 1 divided by negative 3x plus 3 times 15x squared divided by x squared plus x plus 1. First off, we need to do a lot of factoring. We need to factor the x cubed minus 1 as a difference of cubes. We need to factor a negative 3 from the negative 3x plus 3. The trinomial x squared plus x plus 1 is not factorable, so we're going to leave that alone. The result we get after doing all the factoring is parentheses x minus 1 times parentheses x squared plus x plus 1 divided by negative 3 times parentheses x minus 1 times 15x squared divided by x squared plus x plus 1. Next, we could cancel out our common factors, which is the x minus 1s, as well as the x squared plus x plus 1 on both the numerator and denominator. The result is 15x squared divided by negative 3. From here, we could simplify further. 15 divided by negative 3 is negative 5. So we get negative 5x squared for our final answer. Next, we have a practice problem, multiply. For part A, we have 2x minus 3 divided by 5x times 5x plus 5 divided by 2x squared minus x minus 3. For part B, we have x cubed plus 27 divided by negative 2x minus 6 times 4x cubed divided by x squared minus 3x plus 9. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go over part A. So what we need to do here is factor out a common factor of 5 on the numerator, and then factor the trinomial 2x squared minus x minus 3 on the denominator, and then we could bring down the rest of the terms. The result is 2x minus 3 divided by 5x times 5 times the parentheses x plus 1 divided by parentheses 2x minus 3 times the parentheses x plus 1. From here we cancel out all of our common factors, which is the 2x minus 3, the 5, and also the x plus 1. The final result is 1 over x. Moving on to part B, we're going to factor x cubed plus 27 as a sum of cubes. We could also factor a common factor of negative 2 from the negative 2x minus 6, and then the x squared minus 3x plus 9 is not factorable. The result after factoring and bringing down all the terms is parentheses x plus 3 times parentheses x squared plus 3x plus 9 divided by negative 2 times parentheses x plus 3 times 4x cubed divided by x squared minus 3x plus 9. From here we could cancel out all our common factors, which is the x plus 3 and the x squared plus 3x plus 9. The result is 4x cubed divided by negative 2. We could simplify this further. 4 divided by negative 2 is negative 2, so our final result is negative 2x cubed. Next, we're going to go over dividing rational expressions. The rule for dividing rational expressions is p over q divided by r over s is equal to p over q times s over r equals ps divided by qr, as long as q not equal to 0, s not equal to 0, and r not equal to 0. So to divide rational expressions, we just flip the second fraction and change the operation from division to multiplication. For example number 6, divide. For part A, we have 8m squared over 3m squared minus 12 divided by 40 over 2 minus m. First, we're going to flip the second fraction and change the operation from division to multiplication. So we get 8m squared divided by 3m squared minus 12 times 2 minus m divided by 40. From here I'm going to factor out a common factor of 3 from the 3m squared minus 12. I'm also going to factor out a negative from the 2 minus m, and then bring down everything else. The result is 8m squared divided by 3 times parentheses m squared minus 4 times negative parentheses m minus 2 divided by 40. Next, I could factor the m squared minus 4 as a difference of squares and bring down everything else. We get 8m squared divided by 3 times the parentheses m minus 2 times parentheses m plus 2 times negative parentheses m minus 2 divided by 40. Next, we could cancel out a common factor of m minus 2 on the numerator and the denominator. We can also multiply the 3 and the 40 on the denominator. The result is negative 8m squared divided by 120 times the parentheses m plus 2. Next, we could simplify further by reducing negative 8 over 120. The final result is negative m squared divided by 15 times the parentheses m plus 2. Moving on to part B, we have x squared minus 25 over x squared plus 5x plus 4 divided by x squared minus 10x plus 25 over 2x squared plus 8x. First, we're going to flip the second fraction and change the operation from division to multiplication. The result is x squared minus 25 divided by x squared plus 5x plus 4 times 2x squared plus 8x divided by x squared minus 10x plus 25. Next, we simplify by factoring. The x squared minus 25 can be factored as a difference of squares. We could factor out a common factor of 2x from the 2x squared plus 8x. We could factor the x squared minus 10x plus 25 as a perfect square trinomial, and then we could factor the x squared plus 5x plus 4 using the x method. The result after factoring is parentheses x minus 5 times parentheses x plus 5 divided by parentheses x plus 1 times parentheses x plus 4 times 2x times the parentheses x plus 4 divided by parentheses x minus 5 times parentheses x minus 5. Next, we could cancel out the common factors of the x minus 5s and the x plus 4s on the numerator and the denominator. The result is 2x times the parentheses x plus 5 divided by parentheses x plus 1 times parentheses x minus 5. Next, we have a practice problem, divide. For part A, we have 12m cubed over 5m squared minus 5 divided by 6 over 1 minus m. For part B, we have x squared minus 16 over x squared plus 5x plus 6 divided by x squared minus 8x plus 16 over 3x squared plus 6x. Alright, so go ahead and pause the video, try out these problems, and then check back with the video to see the solutions. Alright, so let's get started with part A. First, we flip the second fraction and change the operation to multiplication. We get 12m cubed divided by 5m squared minus 5 times 1 minus m divided by 6. From here, we could factor out a common factor of 5 from the 5m squared minus 5. We could also factor a negative from the 1 minus m. The result is 12m cubed divided by 5 times the parentheses m squared minus 1 times negative parentheses m minus 1 divided by 6. Next, we can factor the m minus 1 as a difference of squares. The result is 12m cubed divided by 5 times the parentheses m minus 1 times parentheses m plus 1 times negative parentheses m minus 1 divided by 6. From here, we can cancel out the common factors of the m minus 1s. We can multiply the 12 and the negative sign and the 5 and the 6 on the denominator. The result is negative 12m cubed divided by 30 times the parentheses m plus 1. Next, we could simplify further by reducing negative 12 over 30. The final result is negative 2m cubed divided by 5 times the parentheses m plus 1. Moving on to part B, we first flip the second fraction and change the operation to multiplication. We get x squared minus 16 divided by x squared plus 5x plus 6 times 3x squared plus 6x divided by x squared minus 8x plus 16. Next, we factor the x squared minus 16 as a difference of squares. We could factor out a common factor of 3x from the 3x squared plus 6x. We could factor the x squared minus 8x plus 16 as a perfect square trinomial, and then we could factor the x squared plus 5x plus 6 using the x method. The result is parentheses x minus 4 times parentheses x plus 4 divided by parentheses x plus 2 times parentheses x plus 3 times 3x times the parentheses x plus 2 divided by parentheses x minus 4 times parentheses x minus 4. From here, we can cancel out the common factors of the x minus 4s and the x plus 2s on the top and the bottom. We get our final result, which is 3x times the parentheses x plus 4 divided by parentheses x plus 3 times parentheses x minus 4. For example number 7, perform each operation. We have x squared minus 25 over parentheses x plus 5 squared times 3x plus 15 over 4x divided by x squared minus 3x minus 10 over x. The first step I'm going to do is flip the third fraction and change the operation from division to multiplication. We get x squared minus 25 divided by parentheses x plus 5 squared times 3x plus 15 divided by 4x times x divided by x squared minus 3x minus 10. Next, I'm going to factor the x squared minus 25 as a difference of squares. I could factor out a 3 from the 3x plus 15, and I could factor the x squared minus 3x minus 10 using the x method. The result is parentheses x minus 5 times parentheses x plus 5 divided by parentheses x plus 5 times parentheses x plus 5 times 3 times the parentheses x plus 5 divided by 4x times x divided by parentheses x minus 5 times parentheses x plus 2. Next, we could cancel out the common factors of the x minus 5s, the x plus 5s, the second set of x plus 5s, and also the x's. The final result is 3 divided by 4 times the parentheses x plus 2. Next, we have example number 8. For the ICL production company, the rational function capital C of x is equal to 2.6x plus 10,000 divided by x. This function describes the company's cost per disk of pressing X compact disc. Find the cost per disk for pressing 1,000 compact disc. In order to find the cost per disk for pressing 1,000 compact disc, all we need to do is take 1,000 and substitute it in for x into the C of x function. We get C of 1,000 equals 2.6 times 1,000 plus 10,000, all divided by 1,000. Next, I'm going to multiply the 2.6 and the 1,000. This is equal to 2,600 plus 10,000 divided by 1,000. Next, we could add the 2,600 plus the 10,000 on the numerator. This is equal to 12,600 divided by 1,000. Simplifying further, we get 12.6. This means that the cost per disk is $12.60 when 1,000 disks are pressed. Okay, so we reached the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.